Hi students, good evening. Welcome to this video session. I remain Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall discuss your section 3.3 homework assignment. Section 3.3 homework assignment deals with the measures of spread or measures of variation or measures of variability. So you can say measures of spread or measures of variation or measures of variability. And this includes the variance, the standard deviation, and the range. Some of the questions we will also see in section 3.3 will also include some measures of position as well, such as the empirical rule and the Chebyshev's theorem. As usual, we are going to just use technologies to solve this assignment. And the two technologies we shall use are my calculator, or rather my calculators, and the Pearson Statcrunch software. So let's begin. Question 1. We shall do some questions with my calculator, and we shall do some other questions with Statcrunch. Question 1, identify the symbols used for each of the following. Sample standard deviation is S, lowercase s. And let's go ahead and pull up my calculator. Let's open up Firefox. And as it's going on, the symbol for sample standard deviation, that is your S. Population standard deviation is the sigma. Okay. Sample variance is S squared, your S squared, and the population variance is sigma squared. So let's go to my calculator, go to Google, and you can type in my name and go to my mobile friendly sites. You can actually click on portfolios and you can see several calculators here. So we're going to use the descriptive statistics calculator. And if you click here, symbols meanings, here you will see these. S squared is your sample variance, sigma squared is your population variance, S is the sample standard deviation, sigma, this is lowercase sigma, okay? This lowercase sigma is a Greek alphabet, and this is uppercase sigma. Uppercase sigma means summation, but lowercase sigma means population standard deviation. Then lowercase sigma squared is the population variance. So that is this, okay? Question 2, listed below are the top 10 annual salaries in millions of dollars of TV personalities. Find the range, variance, and standard deviation for the sample data. Given that these are the top 10 salaries, do we know anything about the variation of salaries of TV personalities in general. So let's kind of do this this one with Statcrunch. I'm gonna show you. You just click right here and open in Statcrunch. I want to have this side by side, so that way we could look at it side by side. Okay, I will name this data to be salaries. And we'll go to Start, Summary Stats, Columns. Select Columns, select the salaries, and we need to find range, and then you hold down. Now I'm using a Windows machine. I'm using Windows PC to do this, so I will hold the shift, the control or the shift. Okay, I'll hold the control key, I hold it down, then I look for variance. So you look for variance. As you can see here, we have variance, and then we have unadjusted variance, and then we also have the standard deviation, and we have unadjusted standard deviation. So the unadjusted variance is the population variance, and the unadjusted standard deviation is the population standard deviation. But this is a sample. This is a sample. So we're going to use the sample variance and the sample standard deviation. So we just click variance here and then standard deviation. Okay, and you click compute. So the range is 28.5. The variance to 2 decimal places would be 134.54. And the standard deviation to 2 decimal places would be 11.60. Okay. Then it says, is the standard deviation, I can go ahead and close this. Is the standard deviation of the sample a good estimate of the variation of salaries of TV personalities in general? If you see this here, let's look at these options. No, because there is an outlier in the sample data. We don't know if there's an outlier unless we check, but it has nothing to do with the question. Okay, this option A has nothing to do with the question, so we strike it off, eliminate it. B, no, because the sample is not representative of the whole population. Okay, B is correct. C, yes, because the standard deviation is an unbiased estimator. No, standard deviation is a biased estimator. Okay, it's a biased estimator. The sample standard deviation does not reflect the true value of the population standard deviation. So we say it's a biased estimator. So C is out. D, yes, because the sample is random. This we won't say is random because they said it's top 10 annual salaries. So the correct option would be B. Okay. Question 3. 6 different second-year medical students at Bellevue Hospital measured the blood pressure of the same person. The systolic readings in millimeter mercury are listed below. Find the range, variance, and standard deviation for the given sample data. If the subject's blood pressure remains constant and the medical students correctly apply the same measurement technique, what should be the value of the standard deviation? So in this case, let me use my calculator. In my calculator, I'm gonna click on measures of spread. If you were taking this, and I keep saying this, okay, I know why I'm saying it. If you were taking this course in class, then my calculator would be much more better for you to show your work. My calculator is much better for you to show your work. My calculator, there are two ways to calculate measures of spread, two methods. So this is the first method, and if you scroll down, measures of spread, you see the second method. It will give you the same result. And these are actually two different ways to calculate the standard deviation and the variance. If you please, let me say this. Before you continue with this video, before you view this video, it is my expectation that you have already reviewed the videos and notes of descriptive statistics. Okay, it's my expectation that you have already read the notes and viewed the videos. Then you can now view this video. Then you can now do your homework assignment. So I've done videos of how you can calculate this by hand. I did it already. And then if you go to formulas, you will see the two different formulas for calculating standard deviation and the variance. You have two different formulas. So I used one formula for what I call first method, and I used another formula for second method. And you just use any of the formulas you want. Some of your textbooks list only one method, but I did this with two different methods for the variance and standard deviation. So you just use any one you like, okay? Or the one that your professor wants you to use. So with this calculator, it shows you the steps on how to calculate the standard deviation and the variance. Kind of shows you the steps so that you don't make, if you make any mistake in any of these steps, you go and fix it. If you were taking this course in class, these are the steps that your professors will want to see. Usually you arrange it in columns to show all your work. Your professor wants to see all these columns before you arrive at your final answer. And if you are taking the second method, this is the columns he or she wants to see before you arrive at your final answer. So we can use any of these methods, it doesn't matter. We put 127, 145, 126, 146, 140, and 123. And then you just come here and you press calculate. Okay. So the range is 23 millimeter mercury. The sample variance is this S squared, and they want it to the nearest tenth as needed. Sample variance is 106.7. Okay. Sample standard deviation to the nearest tenth as needed is 10.3. 10.3. Okay. What should be the value of the standard deviation? The 6 different second year students measured the blood pressure of the same person. Okay, and they correctly apply the same measurement technique, what should be the value of the standard deviation? A. Ideally, the standard deviation would be 1 because all the measurements should be the same. B. Ideally, the standard deviation would be 0 because all the measurements should be the same. C. Standard deviation would be 1 because this is the lowest standard deviation that can be achieved. Okay, still we strike it off. Now, all the measurements will be the same anyway, and there should be no deviation. There should be no deviation. D. There is no way to tell what the standard deviation should be. No, that's not true. Ideally, the standard deviation should be 0. Okay, because the six medical students, they measured the blood pressure of the same patient and they correctly apply the same measurement technique. So they should get the same result. There should not be a deviation. Ideally, in the ideal case, there shouldn't be any deviation. Okay, from the measurements, they should have the same measurement. Ideally. Okay, so that should be option B. Question 4. Listed below are the gross amounts in millions of dollars and in box office receipts for a recent movie. The amounts are listed in order for the first 14 days of the movie's release. Find the range, variance, and standard deviation of the data set. If you invested in this movie, what characteristic of the data set would you care about most? And is it a measure of Senna or measure of variation? Okay, this question, let's use Statcrunch. I will open in Statcrunch. So we use Statcrunch, we use my calculator, we use Statcrunch, we use my calculator. Okay. I just want to rename this variable to amounts, gross amounts. You can just say, you can use camel casing, gross amounts. We call this camel case, excuse me, gross amounts. So we go to start, summary starts, columns, select it. We click on range first, then hold down the control key, select variance, and then select standard deviation. Okay, compute. The range is $53 million. The variance to 1 decimal place is 379.8. Okay. The standard deviation to 1 decimal place is $19.5 million. If you invested in this movie, what characteristic of the data set would you care about most? And is it a measure of Senna or variation? A, the variance, and it's a measure of variation. B, the standard deviation, and it's the measure of variation. C, the gross from opening day and the rate of decline. The measures of Senna and variation are less important. D, the standard deviation, and it is the measure of Senna. D is out already. Standard deviation is not a measure of Senna. E, the variance, and it is a measure of Senna. E, variance is not a measure of Senna. So we can eliminate D and E. Now, let's look at ABC. The variations in this case, because you invested Whenever you invest, you want a good return on your investment. You want to know, okay, what's the gross from the opening day and what's the rate of decline. So variance and standard deviation in this case is not necessary for us. Okay, so I would go with C. Question 6, we can use my calculator. Listed below are the numbers of manatee are the, we call them sea cows, right? Listed below are the numbers of manatee deaths caused each year by collisions with watercraft. The data are listed in order for each year of the past decade. Find the range, variance, and standard deviation of the data set. What important feature of the data is not revealed through the different measures of variation? So I think we used measures of spread first method. Okay, let's use the second method this time, just to show you both methods work. Now you can ask me, what is the difference between the two methods? Okay, with this one, the first method, you have to find the mean. You have to find the mean before you use the formula, and this pertains to calculating the variance and the standard deviation. Okay, it's two different formulas. So the first method, you have to find the mean. The second method, the formula it uses does not need, you don't need the mean. You don't need to find the mean of the data set if you're using the second formula. And you see these formulas in my notes. Okay, actually you also see it in this calculator. You will see formulas in this calculator. If you open it, you see formulas, and you will see the two different formulas. Okay, so let's use the second method this time. We have 67, 80, 78, 82, 68, 89, 80, 83, 84, 77. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, calculate. Excuse me. So the range is 22. The variance to 1 decimal place as needed. Variance is 46.8. Standard deviation to 1 decimal place as needed is 6.8. What important feature of the data is not revealed through the different measures of variation? The measures of variation reveal nothing about how the numbers of manatee deaths are spread. That is right, it doesn't tell us anything. B, the measures of variation do not reveal the differences between the largest number of manatee deaths and the smallest number of manatee deaths in the data. It does tell us how they vary. From year to year. C, the measures of variation reveal nothing about the pattern over time. Okay, look at A and C for a moment. B is right. Okay, it tells us the difference. But A and C, the measures of variation reveal nothing about how the numbers of manatee deaths are spread. Let's look at A again. Measures of variation or measures of spread. So A is incorrect. The measures of variation actually tell you how they are spread, how the number of manatee deaths are spread year by year. Okay. They didn't tell us what year we had 67 deaths of manatees. They didn't tell us. Okay, but let's say, they didn't tell us the exact year, but these are the number of manatee deaths over a decade, over 10 years. So the measures of variation kind of tells you that how the numbers are spread. So, but it doesn't tell you, it reveals nothing about a pattern over time. So I will go with C. Question 6. Listed below are the durations in hours of a simple random sample of all flights of a space shuttle program. Find the range, variance, and standard deviation for the sample data. Is the lowest duration time unusual? Why or why not? With this question, I know is turn for Statcrunch, but I see another question here. Is the lowest duration time unusual? So remember when we did measures of position, let me maximize this. Measures of position, z-scores tells you whether the data value is usual or unusual. Okay, and then here tells you the boundaries of usual and unusual data values. So with this particular question, I will prefer to do it with my calculator so that I can actually know that. So I can use my calculator and finish the whole thing rather than I do with Statcrunch, then I come back to look at the usual or unusual. So I'm going to first of all go to measures of spread, and we can just reset. Let's clean up this so we can use the first method. Like I said, you can use any of the methods, but let's click reset. We can use the first method. So we'll type 78, 99, 230, 195, 162, 268, 194. And this also helps you to practice typing, how to correctly input data. Okay, you need to know how to correctly input data. So 268, 194, 371, 252, 239, 382, 330, 226, 244. And you click on calculate. So if you were doing this by table, you can check your answers for all these steps. If you were doing this by hand, you check your answers for all these steps, okay, to make sure that they are right. Okay, the range is 304 hours. So if you get this, you want to look at to see whether we actually put in everything, and that is the only thing about this. We probably, there's some data we probably missed, so we go and check it again. Actually, it's good to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I didn't put 0. Okay, 0. So that is the only, you have to really be careful when you're inputting data. You see, I didn't put 0, so I missed it. And that will affect the sample size. So I'm going to do this again. It doesn't matter, just press calculate. It will do it again. And then we can now put it in now. The sample size is 15 rather than 14. Okay, so you can check this to make sure that it's right. Okay. So the range is 382. Okay. The variance is 10954. The standard deviation to 1 decimal place. Standard deviation to 1 decimal place is 104.7. 104.7. Is the lowest duration time unusual? Why or why not? So remember, we say that a data value here we can pull up a calculator and do this with calculator, but we can also just find, since we know the mean is 218 and the standard deviation is this, we can tell, okay, and the lowest duration time is 0. So we can tell whether it is usual or unusual. But remember, usual and unusual, we say that the data value is unusual if it is 2 standard deviations below the mean or 2 standard deviations above the mean. That's your z-score. Okay, your z-score. If the z-score is less than -2, then that data value is unusual. Also, if the z-score is above 2, then the data value is unusual. So it should be within 2 standard deviations of the mean. If it is less than 2 standard deviations below the mean, then that data value is unusual. That means the z-score is less than -2. Also, if it is more than 2 standard deviations above the mean, that means the data value is unusual. So which means that the z-score is above 2.00. So what we could just do, we could use a calculator to find 2 standard deviations below the mean and 2 standard deviations above the mean. But why do it when I have already done it here? So I'm gonna go here. I'm gonna show you something now. Our mean is 218, and these are standard deviation. Let us copy our standard deviation. I'm gonna right click, copy. And the mean is 218, and the lowest, because they say lowest duration time is 0. The lowest duration time is 0. So I'll come back here. I'm gonna go to measures of position, and I will put 0 here. I will put 0 is the data value. The mean is 218, and the standard deviation, I paste it, and you see the data value is unusual because the z-score is -2.08. So the z-score is less than -2. It is -2.08. So it's less than -2. Okay, so the data value is unusual. So A, no, because it is within 2 standard deviations of the mean. You eliminate A. That is not the answer. B, no. The data value is unusual, period. Is unusual. So A and B, eliminate it. Eliminate A and B. Okay, the data value is unusual. We don't look at usual and unusual data values based on the sampling method. Okay, we look at it based on z-scores. C and z-score tells you how many standard deviations from the mean that data value is. It tells you, okay, that data value is how many standard deviations from the mean. When we say from the mean, it means how many standard deviations below the mean, and also how many standard deviations above the mean. That is what z-score tells you about. Okay, the number of standard deviations from the mean, or you can say the number of standard deviations above the mean and below the mean. Because when we say from the mean, we mean above the mean and below the mean. Or if you say within the mean, it still means above the mean and below the mean. So A and B, we eliminate it. C, yes, because the lowest value in a data set is usually an outlier. No, we eliminate C. Okay, for us to find outliers, we have to find the fences. Remember, it is an outlier if it is lower than if it is less than the lower fence, or if it is greater than the upper fence. So fences identify outliers. So C is incorrect. We eliminate it. D, yes, because it is more than 2 standard deviations below the mean. D is also incorrect. It is yes because it is less than, not more than. Okay, negative 2.08 is less than negative 2. So it is less than 2 standard deviations below the mean. So I'm supposing that this is a typo. I suppose that it is a typo. So if Pearson has the chance to look at my video, they can give me an award, right? They can give me an award for spotting the typo, right? Or they can give me something tangible, right? Or you know, they can. Well, anyway, let's continue. But this should be because actually there's no option that is correct here. But it should be yes, because it is less than 2 standard deviations below the mean. Okay, it is less than negative 2. 2 standard deviations below the mean is a z-score of negative 2. So it is less than negative 2, not more than negative 2. Okay, so just take note of that. This is because it is less than 2 standard deviations below the mean. Question 7. Listed below are the amounts of mercury in parts per million, or ppm, found in tuna sushi sampled at different stores. Find the range, variance, and standard deviation for the set of data. What would be the values of the measures of variation if the tuna sushi contained no mercury? If the tuna sushi contained no mercury, then this will be 0, 0, 0, 0, 0, 0, 0. Right? This was sampled at 1, 2, 3, 4, 5, 6, 7, 7 samples. These 7 samples of tuna sushi. Okay, let's do this with Statcrunch. Let's do this one with Statcrunch. So click here, open in Statcrunch, and if I let me name this data. Let me name the variable mercury levels, or mercury amounts in tuna sushi. Okay, I'm gonna go to stats, summary stats, columns, select mercury levels, Select range, hold the control key, select variance, and then standard deviation. Compute. So the range is 0.72 parts per million. The sample variance to 3 decimal places would be 0.0 3 decimal places as needed. Okay, sample variance to 3 decimal places as needed would be 0.080. Okay, sample standard deviation to 3 decimal places as needed would be 0.282. Okay, what would be the values of the measures of variation if the tuna sushi contained no mercury? Oh wow, they will all be 0, because this will be 0.0000000 mercury, right? So they will all be 0. Question 8. Listed below are the arrival delay times in minutes of randomly selected airplane flights from one airport to another. Negative values correspond to flights that arrived early before the scheduled arrival time, and positive values represent lengths of delays. Find the range, variance, and standard deviation for the set of data. Some of the sample values are negative, but can the standard deviation ever be negative? Okay, let's of course with the formula for standard deviation, it can never be negative, because the standard deviation is the square root of the variance. The variance is s squared, and of course if you square, the square of any number must be positive. If you square a positive number, it gives you a positive number. If you square a negative number, it still gives you a positive number. So when you take the square root of a positive number, standard deviation is the square root of the variance. So the square root will always be either 0 or positive. Okay, when we say positive, we mean above 0, numbers above 0. Those are positive numbers. Now when we say non-negative numbers, I'm not talking algebra. If we say non-negative, that means it is 0 and positive. Okay, when we say non-negative, it means 0 and positive. Okay, so let's do this with my calculator. Let's use measures of spread, second method. I'm gonna reset this, and I'll put in this data. Or we can use first method. It says here some of the sample values are negative, but can the standard deviation ever be negative? No, it can never be negative. But let's use the first method, because I want to show you something here. I will put in this 9, 14, negative 29, and you can use the second method if you want to, but I wanted to show you something here. So 9, 14, negative 29, 9, 13, negative 32, and negative 15. Okay, calculate. The range, now let 1, 2, 3, 4, 5, 6, 7. Sample size is 7. Okay. The range is 46. The variance S squared is 413. Anything you square, the variance must always be positive. If you square anything, it will give you a positive number. So to one decimal place, it will be 413.3. Okay. The standard deviation to one decimal place will be 20.3. Some of the sample values are negative, but can the standard deviation ever be negative? No. Okay, the standard deviation can never be negative. So you eliminate A and B. Now look at C. No, because the squared value in the standard deviation formula can be negative. No, squared is always positive, squared. Okay. No, because the squared value in the standard deviation formula cannot be negative. That's the answer. Okay. And you can do this with the second method if you want to. Question 9. Fuel consumption is commonly measured in miles per gallon. An agency designed new fuel consumption tests to be used starting with 2008 car models. Listed below are randomly selected amounts by which the measured miles per gallon (mpg) miles per gallon ratings decreased because of the new 2008 standards. Find the range, variance, and standard deviation for the sample data. Is the decrease of 4 miles per gallon unusual? Why or why not? I would like to do this with my calculator because of the usual and unusual. But what we could do is we can do this with Statcrunch, but I will need to get the mean also. Okay, I'm gonna need to get the mean, and then I can finish it up with my calculator. So I will open in Statcrunch. These are fuel consumption in miles per gallon. So I'll just put mpg here. Okay, I go to start, summary stats, columns, select the fuel consumption in miles per gallon. Let me first of all get the range, then I get the variance, then the standard deviation. Then I will need the mean just to finish this with my calculator. Okay, for the other question. So I'm going to click compute. The range is 3 miles per gallon. The variance to one decimal place is 0.6 miles per gallon. The standard deviation to one decimal place is 0.8 miles per gallon. Then it says, is the largest decrease, which is 4 miles per gallon, is it unusual? Why or why not? So what I'm going to do here, folks, this standard deviation, I don't want to round it. I don't want to round this. So I'm going to minimize this first. Let me see what I can copy it. Okay. I copy this. Copy. Now let me close this. I will get to my calculator. Now what was the mean? The mean was what again? Ooh. Before I closed it, I would have got the mean. Let me just go here and get the mean. Summary stats, columns. Mean was mean is 2.1. Okay, so I'm gonna come here to my calculator, measures of position. I will reset this. The data value is 4. Okay, that's the question. 4 miles per gallon. Is it unusual? The mean is 2.1, and the standard deviation, I paste this. I press calculate. Yes, it's unusual. It is unusual, and they want us to know because it is more than 2 standard deviations from the mean. Okay, so if you really, let's go here to now tell the boundaries. Let's go here to actually tell the boundaries. If you come back here, the next one, it says tell the boundaries of usual and unusual data values. So the mean is 2.1 and the standard deviation, paste. So the boundaries are between 0.52 and 3.66. So 4 is above 4 is above 3.67613786. So 4 is above, is more than 2 standard deviations above the mean. That's why it's unusual. So you look at here, A, the decrease of 4 miles per gallon is unusual because it is more than 2 standard deviations from the mean. I will say above the mean. Okay, I will say above the mean. Let's look at B. B, the decrease of 4 miles per gallon is not unusual. Well, it's unusual, so strike off B. C, the decrease of 4 miles per gallon is unusual because the smallest value in the data set is usually an outlier. Strike off C, that is wrong. D, the decrease of 4 miles per gallon is not unusual, it's unusual. Strike off D. So it's A, but I would go with the decrease of 4 miles per gallon is unusual because it is more than 2 standard deviations above the mean. Okay, and you can check answer. Okay, question 10. The trend of thinner beauty pageant winners has generated charges that the contest encourages unhealthy diet habits among young women. Listed below are body mass indexes, BMI, for beauty pageant winners from 2 different time periods. Find the coefficient of variation for each of the 2 sets of data. Then compare the variation. I can do this with my calculator, but because we are comparing, let's just use Statcrunch. If you're going to use my calculator, it is under measures of spread. You see coefficient of variation, CV. This is not curriculum vitae, okay? CV, if you go to the symbol, CV means coefficient of variation. CV, not curriculum vitae. Okay, let's do this with Statcrunch. Okay, I'm gonna click here, open a Statcrunch. It is already it's already defined. The variables are already defined. We go to Stats, Summary Stats, Columns. Now select both of them. Select the first one, then hold your Control key, select the second one. Okay, and we are just looking for coefficient of variation. So scroll down, look for coefficient of variation. There you go. Click on it and click compute. So the first one, coefficient of variation is always in percentage. Okay, we put it in percentage. So to 1 decimal place, this is 7.2%. The second one, the BMIs of recent beauty pageant winners will be 6.5% to 1 decimal place. Is there a difference in variation between the two data sets? So usually we talk about significant difference if it is if the difference is more than 5%. Okay, if the difference is more than 5%, when you do 7.2 minus 6.5, it's not gonna give you anything more than 5%. That is actually 0.7%. So there is no significant difference in the variations. There is none. Okay. Let me close this. Question 11. Listed below are amounts in millions of dollars collected from parking meters. Wow, that's a lot of money. Collected from parking meters by a security service company and other companies during similar time periods. Do the limited data listed here show evidence of stealing by the security service company's employees? Okay. First of all, they want us to find the coefficient of variation for each of the two samples. So we click this, open in Statcrunch. Start, summary starts columns, select the two, then look for coefficient of variation. There you go, compute. So the first one to 1 decimal place is 11.0%. The second one to 1 decimal place is 7.0%. Do the limited data listed here show evidence of stealing by the security service company's employees? Consider a difference of greater than 1% to be significant. Of course, the difference here is 4% approximately. So it is significant if we are considering a difference of greater than 1% to be significant. So yes, so options A and D, we eliminate them. Yes, there is a significant difference in the variation. Yes, B. Okay. Question 12. Listed below are contributions in dollars made to two presidential candidates in a recent election. Find the coefficient of variance for each data set. Is there a difference in variation between the two data sets? Okay, let's find the coefficient of variation. Click, open in Statcrunch. Start, summary starts columns, select the two candidates and click coefficient of variation, compute. Candidate A, coefficient of variation to 1 decimal place is 30.7. Candidate B is 59.9. Okay, 59.9 to 1 decimal place, 59.9%. Coefficient of variation is in percentage. Okay. Is there a difference in variation between the two data sets? Consider a difference of greater than 1% to be significant. Of course, there is. The A, the contributions to candidate B have significantly less variation than the contributions to candidate A. No, that's the other way around actually. The contributions to candidate A have significantly less variation than the contributions to candidate B. Yes, option B is the answer. Question 13. Waiting times in minutes of customers at a bank where all customers enter a single waiting line, and a bank where customers wait in individual lines at 3 different teller windows are listed below. So you have one bank, all the customers enter a single waiting line, and the other bank, all the customers wait in individual lines at 3 different teller windows. So these are their waiting times here. Find the coefficient of variation for each of the 2 sets of data. Then compare the variation. So open this in Statcrunch. Go to Stats, Summary Stats, Columns. Select the 2 banks. Select coefficient of variation. Compute. So for bank A, the coefficient of variation is 6.5% to 1 decimal place. For bank B, the coefficient of variation is 24.6% to 1 decimal place. Is there a difference between the 2 data sets? Of course, there is. I mean, even if we consider the normal difference of 5%, okay, of course, there is. We see that the waiting times at bank A have considerably less variation than the waiting times at bank B. Okay. Okay. Question 14. Use the magnitudes Richter scale of the earthquakes listed in the data set below. Use technology to find the range, variance, and standard deviation. Okay, just open this in Statcrunch. Open in Statcrunch. And I just like to name my variable. I mean, you must not, but I like to name it. I'll just name this as magnitudes. Magnitudes of earthquakes. Okay, magnitudes. Stats, summary stats, columns, magnitudes. And we want to find the range. Then hold the control key. Then the variance. And then the standard deviation. Compute. So the range to 3 decimal places as needed is 2.86. The variance to 3 decimal places as needed is 0.816. The standard deviation to 3 decimal places as needed is 0.903. Okay. Question 15 is the same method. Okay. Set of times. So I'm gonna do the same thing. Data set of times required to taxi out for takeoff. So I can put this as times. Then start, summary starts, columns, select times. then select range, hold the control key, select variance, standard deviation, compute. Range is 39, variance is 126.3, and standard deviation is 11.2. Okay. Question 16. Below are the range and standard deviation for a set of data. Use the range rule of thumb and compare it to the standard deviation listed below. Does the range rule of thumb produce an acceptable approximation? Suppose a researcher deems the approximation as acceptable if it has an error less than 15%. So we've been using Statcrunch, so let's use my calculator this time around. Range rule of thumb gives you an estimated value of the standard deviation. So just click on range rule of thumb, and the range. Okay, so here they gave you just minimum and maximum, and you have to find the range. But here they just gave you the range. So the range is 2.98. And if we use the range rule of thumb, you just press the enter key, or you press calculate. The range rule, the estimated value of the standard deviation is 0.745. But the actual value of the standard deviation is 0.889. So there's an error, but it is acceptable if that error is less than 15%. So let's see the error difference. Okay, the error is the actual minus the actual value minus the new value divided by the actual value, and then you multiply by 100. So to get it in percent. I repeat, the error would be the error percent. The error percent would be the error divided by the actual times 100. Okay. The error percent is the error, and that error is the actual minus the estimated value. That's the error. We find the error. Then you divide it by the actual, and then you multiply it by 100 to give it to you in percent, error percent. If the percentage is less than 15, then we are good, it's acceptable. If it is not less than 15, then it is not acceptable. Let me kind of pull up a calculator. I'm gonna type in calculator here. Initially, when you type calculator, you might see it this way, standard. You might see it in standard. So just click here and put it in scientific. Okay. So the error is 0.889 minus 0.745. Okay, the error is 0.144. You now divide it by 0.889, and then you multiply by 100. Okay, or you can multiply by 100 and then divide by 0.889. Whichever you want to do, it doesn't matter. So divided by 0.889, then times 100. So the error is 16.198%. That is not acceptable. It is greater than 15%. So, but first of all, let's put the estimated standard deviation. Estimated standard deviation is to 3 decimal places is 0.745. It is not unacceptable because the error of the range rule of thumbs approximation is greater than 15%. Okay. If it is less than 15%, then it's acceptable. Okay, this is another one. This case, the range is 40. The estimated value of the standard deviation is 10. Of course, from range rule of thumb, you just divide by 4. You divide the range by 4. Range divided by 4. That is the range rule of thumb. Let's look at the error. The actual is 12.441, then minus 10, the estimated one. And if it gives you a negative number, you want to take the absolute value. Okay, but the main thing is we are looking at the absolute. Do you want to take the absolute value of the error? Okay, then you multiply this by 100, and then you divide by the original 12.441. So that gives us 19.621%. It's still not acceptable. Is this an acceptable approximation? No. Because the error is greater than 15%. Okay. Let's minimize this. Question 18. A certain group of test subjects had pulse rates with a mean of 79.6 beats per minute and a standard deviation of 12.7 beats per minute. Would it be unusual for one of the test subjects to have a pulse rate of 95.0 beats per minute? Okay, I'm going to do this with my calculator, usual and unusual. So we go to measures of position to get our z-score. The x in this case is 95.0, which is just 95. If you want to put 95.0, that's fine. The mean is 79.6. Standard deviation is 12.7. Okay, and press the enter key or you press calculate. So the minimum usual value, okay, they want us to find minimum usual value. So just go to the next one here. The mean is 79.6. Standard deviation is 12.7. Okay, enter. So the minimum usual value, that is the lower boundary, is the 54.2. 54.2. Okay, the maximum usual value is 105. 105. Oops. 105. 105. Okay. I typed in 10, then I didn't type 5, and I pressed the enter key. Okay. It's 95.0 beats per minute, an unusual pulse rate. It is usual because it is between 54.2 and 105. Is it unusual? No, it is not unusual because it is between the minimum and maximum usual values. Okay. Question 19. Cans of regular soda have volumes with a mean of 12.87 ounce and a standard deviation of 0.11 ounce. Is it unusual for a can to contain 13.07 ounce of soda? Okay, so we go to here. X here will be 13.07. The mean is 12.87. Standard deviation is 0.11. Calculate. And then come here. The mean is 12.87. standard deviation is 0.11. Calculate. So the minimum value, which is the lower boundary, is 12.65. 12.65. Okay. Maximum value is 13.09. The data value is usual, as you can see here, is usual. Is this an unusual volume? No, because it is between the minimum and maximum usual values. Okay. Remember, if it's unusual, that means it is lower than the minimum or greater than the maximum. Okay, so just take that in mind. But if it's between the minimum and maximum usual values, then it is not unusual. Okay. Question 20. Find the standard deviation S, that's the sample standard deviation, of sample data summarized in the frequency distribution table below by using the formula below. Okay, this is the second formula. This is the second formula. And I did that in the video, how you could use this formula. Okay. So they say you should use this second formula where X represents the class midpoint, F represents the class frequency, and N represents the total number of sample values. Also, compare the computed standard deviation to the standard deviation obtained from the original list of data values, and that standard deviation is 11.1. So we'll first of all calculate it, and then we compare our result to 11.1. Okay, this is what you do, folks. Go here, click open in Statcrunch. We will use Statcrunch for this one. You click on Stats, Summary Stats, and click Grouped/Bin Data, because this is a group data. Do not select columns, no. Select this, okay, because it's group data. We did this in a data organization, arranging your data in classes or groups. The bins are in the interval, and the counts are in frequency. Select the bins in interval, counts, frequency, and just look for standard deviation, and click compute. So to 1 decimal place, that gives us 10.2. Okay. Consider a difference of 20% between two values of a standard deviation to be significant. How does this computed value compare with the given standard deviation of 11.1? So let's find the error difference. That's all they're asking about. Let's use let me close this. Let's do actual minus estimate minus given, then divided by the actual times 100/1 to see how many percent it will give us. Okay. The actual is 10.2 minus the given is 11.1, and the absolute value of this is 0.9. Okay, so the absolute value of this is 0.9, so I'm gonna negate it, the absolute value of that. Then you can multiply by 100, gives you 90, then divide by the actual. The actual is 10.2. So this is 8.8%. 8.8%. So the difference of 20% would be significant. Okay, but because this difference is 8.8%, it's not significantly different from the given value. Okay. The next question looks like the same thing. So let's go ahead, open this in Statcrunch. We do this one in Statcrunch. Go to Stat, Summary Stats, Grouped Bin Data. Bins are interval, counts, frequency. Then select Standard Deviation, click Compute. Okay, so this gives us to one decimal place is 9.9. Okay, 9.9. Consider a difference of 20% between the two values to be significant. Okay, so let's just do 9.9, the actual minus the given 9.0, then multiply by 100. Okay, then divided by 9.9, the actual. Okay, and that's 9.09%, so it's less than 20%. So it is not significantly different. Not. Okay. Question 22. Heights of men on a baseball team have a bell-shaped distribution. That's a normal distribution. Okay, with a mean of 172 centimeters and a standard deviation of 7 centimeters. Using the empirical rule, what is the approximate percentage of the men between the following values? Okay, so empirical rule. Let me make this bigger. With empirical rule, we are not going to use this calculator. We will not use this calculator. We are going to use you can go to other calculators. Okay, you can click on other calculators, or you can just get back to my portfolio. When you click on other calculators, it gives you my portfolio. So empirical rule is under probability distribution calculator, because empirical rule is also normal distribution. Okay, normal probability distribution. So when you come here, just scroll down until you see empirical rule. Click on it to take you to it. So this is what we're gonna use. So I'm gonna make this to restore this so it can be on the same window. The mean is 172 centimeters. The standard deviation is 7. Okay, and you click calculate. So if you click calculate, it gives you a whole lot, because I did the whole thing with empirical rule. Please, I have done video on empirical rule, so it is important you also review it. And I'm kind of surprised, because this is a measure of empirical rule is your normal probability distribution. Okay, so let's see how many percent of the men are between 165 centimeters and 179 centimeters. Oh wow, see it right away. 165 and 179 right away. 68%. Okay, then how many percent of the men are between 151 centimeters and 193 centimeters? So 151 and 193. So look for it. 151 and 193. 151 and 193. Look at it here. Okay, 151 and 193. So I did the whole possibilities, so you're gonna find something here. So but 151 and 193, that gives us 99.7 percent. Question 23. Heights of women have a bell-shaped distribution with a mean of 162 centimeters and a standard deviation of 7 centimeters. Using Chebyshev's theorem, what do we know about the percentage of women with heights that are within 3 standard deviations of the mean? Okay, Chebyshev's theorem. So this, you come here, Chebyshev's theorem. Just click here, Chebyshev's theorem. And this is what we're going to use here. So, Chebyshev's theorem. The mean is 162 centimeters. The standard deviation is 7. The K is how many standard deviations from the mean? That is 3. And you press calculate. So this tells us that it says here round to the nearest percent as needed. So at least 89%. At least 89% of women have heights within 3 standard deviations of 162 centimeters. Okay. The minimum height that is within 3 standard deviations of the mean is 141. So this is 141 centimeters. And the maximum height is 183 centimeters. Okay. All right. Okay. I can now minimize this and make this bigger. Question 24. Which measure of variation is very sensitive to extreme values? Histogram mean, range, median. That's range is very sensitive to extreme values. Okay. Question 25. Which of the following is not a property of the standard deviation? A. The standard deviation is a measure of variation of all data values from the mean. That is correct. B. When comparing variation in samples with very different means, it is a good practice to compare the 2 sample standard deviations. That is not correct. C. The value of the standard deviation is never negative. That is correct. D. The units of the standard deviation are the same as the units of the original data. That is correct. B is the option. 26. The range rule of thumb roughly estimates the standard deviation of a data set as range divided by 4. Okay, that's it. 27, I mean. For data sets having a distribution that is approximately bell-shaped, Dash states that about 68% of all data values fall within 1 standard deviation from the mean. That's the empirical rule. Okay, it's empirical rule. It is also known as 68%, 95%, 99.7% rule. Okay. Then the last but not the least, the square of the standard deviation, come on, is called variance. Okay. Okay. And you click save. Thank you so much for listening to this video session. If you have any questions, please ask. And you have a good night.